welcome back. In this video, I'm going to go over one of the gas laws, Charles' law. Charles was a French physicist, and he was interested in seeing how volume and temperature are related to each other. So what Charles found is that volume and temperature are directly proportional to each other. And what that means is that if one is increasing, so if we increase temperature, then volume will also increase if we keep pressure constant. And the reason is, remember that temperature is a measure of the average kinetic energy of particles. So if we increase the temperature, that means that we're increasing the average kinetic energy of the particles. And if we hold pressure constant, if we're not changing pressure, the only thing that could change would be the volume of the gas. So if we're increasing the average kinetic energy of our gas particles, they are colliding with each other more frequently and with the sides of the container, which will cause the volume to get larger. So what Charles' law says is that if we have a constant pressure and a constant number of particles, temperature and volume are directly proportional, which again means if temperature is increasing, then volume is increasing as well. And we can see that relationship on the graph here. We have volume on the y-axis and temperature on the x-axis. And we can see that if we increase temperature, volume is also increasing proportionally. We can look at an example here. If we have a container that has a temperature of 150 Kelvin, a volume of 300 liters, and let's say we're keeping the pressure constant at 1 atmosphere. We're also keeping the number of particles constant. If I took that same container and I heated it up, the volume will increase, so that piston that is there would rise. There's my 5 particles. If I increased my temperature all the way up to 300 Kelvin, you can see the volume has increased. So if we double the temperature, we're going to double the volume. And because these are proportionally related to each other, the relationship would be V1 over T1 because volume is dependent on temperature. If we take the quotient of both of these containers, we'll see that it's equal to a constant. So if I take the quotient of my first container of 300 liters over 150 Kelvin, that's equal to the constant of 2. And if I take my second container, I have 600 liters over 300 Kelvin, and that is also equal to the constant 2. So if I double temperature, that means volume is also doubled. If I tripled temperature, volume would be tripled. So because both of these scenarios are equal to a constant, I can write my equation as V1 over T1 equals V2 over T2. Both sides of the equation will be equal to a constant value. And in this case, with our containers, that constant value is 2. So let's try an example of working with Charles' law. The nice thing about this law is that if we know 3 variables, we can easily solve for the missing variable. Let's say that I have a balloon at 350 Kelvin that has a volume of 4.3 liters. What would be the volume if the temperature decreases to 250 Kelvin? So the first step is to write out what we know. We know that V1 is equal to 4.3 liters. T1 is equal to 350 Kelvin. V2 we do not know, and T2 is 250 Kelvin. My formula is V1 over T1 equals V2 over T2. So to get V2 by itself, we're going to multiply our T over to the other side. So my equation should be V2 is equal to V1 times T2 over T1. So V2 is equal to 4.3 liters times 250 Kelvin over 350 Kelvin. And my unit of Kelvin cancels out. I'm left with a liter, which is what I'm looking for. And my answer is 3.1 liters. So when we're solving Charles' law, pressure has to remain constant and the number of particles has to remain constant. If we're given 3 variables, we can easily solve for the other one just by rearranging the formula. If you want to learn about any other gas laws, make sure and check out my channel. Thank you so much for stopping by.